I'm just going to let the anticipation build. We're live at Loupe. What's up? What's up, everybody?
Hello.
Got my man Jonathan McLean here, concept engineer. Got Carl Robrock sitting in the opposing camera,
Thank
NMC
God.
lead.
Yes.
Got Nathan. Welcome, Nathan. We've got donuts from Blue Star, which are delicious.
Can we get some of those out immediately?
We're going to pump ourselves full of sugar, and we're going to argue intensely for like 30 or 45 minutes. So if that's what you're here for, welcome. Have a seat. Check us out in the comments. We are ready. We are ready to go. So first, agenda. Obviously, the first agenda item is donuts. I'm going to skip that. An apple. An apple. A nod to our health.
Locale.
Okay, so what is Live at Loupe? What Live at Loupe is, and it's this weird idea that we came up with, which is we're having these conversations anyway. We're really excited about technology, bringing new technology to machines. Why don't we just hit live stream and record like we're playing Fortnite or something? And anyone who wants to watch us and learn from us and share with us, come on in. Here you are. This is our shop. This is what we're doing anyway. Let's just roll live. So we're designing a machine, we're working on some interesting projects, really excited to share that with the world. So welcome, thank you for watching. Let's
Cool.
bring us up to speed.
Yeah, so we had a working session last week, and we had Derek Stacy here from BNR. He's our ACOPOS track guru, and it was great to have his input. He threw a wrench into the whole thing.
Good.
Like all the original vision.
Thanks a lot.
Asked a bunch of questions.
For all those
which,
reality checks.
Yeah, and it kind of it was interesting not having the customer here because we couldn't answer a lot of the questions. So you know what we started questioning the original in-feed mechanism. We started coming up with like on-the-fly ideas around other concepts for in-feed, and but whether or not we choose to pursue those ideas is a function of, you know, what are the design objectives, what are the requirements, like will they violate the requirements? I'm not going to spend much time like, you know, doing a bunch of design work on something that is like, oh, that's not going to work because of PPC.
Yeah. Right? What are we trying to do here anyway?
Yeah, and so, you know, we reflected on how we went through the process, and you know, this is a little bit different in that there was a bunch of groundwork done by Ari, so there's a really well-baked idea already that we kind of have to like work backwards through and figure out like, okay, let's like not assume that what we do is an extrapolation of this. We have to question this fundamentally anyway, right? So,
and I'll take a couple lessons from this, which are just like we talked about before this meeting, like. The right people have to be in the room. Like, and I was out. Why was I out? I think I was sick or something. Yeah, I had a cold. I'm still stuffy, so excuse me. Right people got to be in the room for the meetings, and the why has to be really clear. Like when I put that deck out and I was like, here's this machine that we're designing, it was already, here's the solution. The solution to what? Like, nobody talked about that. The other thing, sort of catching up on it, and sort of after all these conversations, I was reminded, oh yeah, we have a whole bunch of simulations of the actual process here that no one knew about except for me and David Blackburn he did them a year ago, of like, here's us hitting this many cases per minute, here's us hitting this many products per minute, how many cases per minute are we trying to hit, all that kind of stuff. Like, we have a bunch of background work that didn't make it into the brief, and so yeah, as we try to solve it, it's like, oh, we don't know even what the envelope, what are we trying to do here? So I think it's a normal part of the design and NMC process, and so yeah, I think the interesting conversations are like, let's write down the why as close as we know it, and then I guess the other agenda items we wrote down were sort of what do we want to do about the in-feed and what do we want to do about timing studies, and hopefully we can cover that in like 30 minutes maybe, and I'm fine if we go a little bit long, but
okay.
You guys have anything to add to that?
Well, yeah. One of the discussions was, is this going to be useful for something like a rainbow pack where you have multiple products that are being packaged into one case, or is it just going to be a single product, and that kind of will drive the in-feed system decisions?
Yeah, I can talk about that. So I'll put that under the why and what the better problem definition is. I'll put rainbow packs ? You got anything that you've been pondering that we could get in that touches on requirements or anything else you want to bring up, talk about today?
Well, just one thing that we talked about in the last work session too, was just the idea of how to handle rejects.
Yeah,
I don't know
yeah.
if that necessarily can make it into this session, but it's kind of like a fundamental thing to ponder.
Yep. And we got a great comment on our LinkedIn too, because we have awesome social media, which you should totally participate in. I know you're just burning with those questions. Criticize, attack, attack. Please do. Please do. Let's engage. I think his name was Sean. Did you guys see that comment? He was like, hey, friction's not that consistent. You're going to have, you're asking for mis transfers if you don't have some way of like capturing them positively. And I had heard kind of like whispers of, hey, what about the in-feed mechanisms? And so I think maybe that'd be something that we could talk about as far as some of that will fall out of the problem definition maybe, but some of it will be like, hey, how do we want to handle this? Because there's some people are raising some eyebrows at that.
Right. So I guess, the question of like why is a little bit different than design objectives, but design objectives will follow from the why.
Mm-hmm.
And system requirements will follow from design objectives. So in any case, yeah, I guess you want to reiterate the problem statement.
Yeah, and you guys take notes and tell me what you hear,
Yep.
because what's in my head will not always come out of my mouth. So let's try to verify that as much as we can, try to get that dialed so we all know what we're all kind of pointing in the same direction. So one of the inspirations for the track is there's a lot of flexibility in the positioning of products. There's really high speed throughput for this type of machine. And so we were looking at different applications in packaging and asking, how could we bring this technology to this process in a facility and maybe do something interesting or new? And one of the places that popped out right away was this idea of case packing. Here's what's complicated about case packing. There's a lot of different types of case sizes. So a typical company, CPG company that makes things that go into round cylinderish things, whether that's laundry detergent or shampoo or drinks or whatever, round consumer products. They have a lot of variety and a lot of different pack sizes. And one of the long time ways of doing this is there's a lot of timing screws and other types of mechanical change out parts that need to be exchanged when those machines change from one type of case or one type of product to another type of case. So the fundamental motivation from our perspective was, hey, maybe this technology could be a piece of how to unlock this. You don't have to change out any mechanical tooling to change between products and case sizes. Like, I would argue that as the fundamental motivation. So one level deeper on that, why do you
That's
care
a
about
design
that?
objective, by the way.
Okay.
Yeah.
Yeah. It might be yes. Why do you want to do that? It's because it takes time, like in minutes, like 30 minutes, to change out those mechanical parts and to get the machine kind of tweaked and adjusted and dialed. You have to like reset the line, and it takes minutes, let's say 30 minutes of time. And that's time when you're not running. And so, of course, like having all this cool technology ideas, we sometimes think like, well, how can we get the changeover time to 0 seconds? It's like, it doesn't need to be 0, but if it was 5 seconds, it would be revolutionary compared to 30, 40 minutes. So like, that's the ballpark where we're looking at. If it was a minute because we needed time to clear, people's minds would still be blown if that was possible and economical, and it worked. Another motivation for the type of machine is because of that flexibility, you don't need maybe as much space. You don't need those machines that hold the fixed tooling anymore. So that machine just goes away. Footprint goes away. All of the programming, adjustment, service, metal, everything about that machine goes away, including the amount of space that it takes up. So that's really valuable. And if a machine was flexible and it could conform to the product in different ways, again, over time, you can ship the machine without knowing this is exactly what product's going to run in it. So it can run products that haven't been anticipated. They can make changes to the product without having to like this big back and forth process with the equipment builder. So that's my off the top of my head answer of what the motivation or like what's the genesis of this idea. And what I would add to that is, we have notions from being in facilities and looking at equipment of like what good throughput is what's considered to be good throughput. I don't really know where that comes from, but we've looked at different machines, and it's like this many hundreds of products per minute, this many cases per minute is what we're looking for. Typical equipment builder, that's what they're handed by their customer when they say, hey, we've got yogurt, we've got cans, we've got, this is what we need to put in these boxes. Like that's the spec that comes from the end user, and we just have like order of magnitude. It doesn't have to be perfect because we know like here's how we could scale it if we needed to go higher. The main motivation is not like let's try to make a machine that runs 10 times faster, but let's try to make a machine that's super flexible, that can change over in less than a minute, and take all those different case sizes and different types of products.
Yeah. Okay.
So that's the brief. You guys have been digging around on it. What am I missing, or like what do you feel like could benefit from clarification?
Well, one of the things so what I wrote, just real quick, what I wrote down as the why is there's a need for the packaging in general has a need for, or has a wide variety of packaging sizes, different case sizes, which dictates and the packaging arrangements are tied to hard tooling, which means timing screws and change out parts that are almost like you have combinatorics issues, right?
Mm-hmm.
So it's
many dimensions.
It's exponential, right? It
Yeah.
becomes a non-solvable problem at some point. And there's change out timing, downtime, and there's arguably more changeover happening with more proliferation of different packaging.
Yeah.
Different types of packaging. So what you're trying to do is just massively reduce the changeover time and cost and footprint, and maybe even augment the flexibility beyond what is done today, even with those kind of brute force approaches.
Yeah.
So
right now, part of the reason that there's so many variations is there's all different kinds of channels for those products. There's all different kinds of ways they want to package them. The marketing people at those companies want to come up with these like minor variations to run different tests on them.
Yeah.
If their production systems can't deliver that, then they're limited in sort of like exploring what consumers want, which I think is the ultimate motivation and like where a lot of the capital and interest and investment is coming from. Like it's so that the marketing people can be like, hey, we want to try this. Production people are like, no problem. Tap, tap, tap. Machine changes over. They've never seen that product before. Like that's something that I think would be really special if we could get it out there. And that's that makes it when you're talking about not just changeover but also new product introduction.
Right.
As something you could just punch into the machine versus let's go cut some new screws on the lathe, like and you would not even try it, right? You wouldn't even try that. So that's, or you'd be limited within like stuff that you've done before.
Right. So design objectives that come out of that are no mechanical changeover parts, massive reduction in changeover time. So like maybe there's some purging that has to happen, but like it's the order of magnitude is 5 seconds versus 30 minutes.
Yeah.
Reduced footprint is a nice to have. It's hard to put a value on that, but it's probably going to take up a lot less space. And accommodating a wide variety of product size, right?
Product and case
tooling.
Combinations. Yeah.
Okay. So one of the things that one of the questions that came up, again, the idea of rainbow packing, right? Like that is not part of the original scope, right? Like the problem statement did not include rainbow packing, right?
Right.
So,
that's a new idea.
Right. That's a new idea. But
or a related idea, maybe.
It's a related idea, right? And so I guess as we look into in-feed mechanisms, we also had the realization last time around when we were talking to Derek. He had his water bottle here, his stainless steel water bottle full of water, and
we were chucking it on the tooling.
Yeah, and we're like, ooh, that's loud, like that's, and just the realization that that's dramatically different. The physics of that, or the surface coefficient of friction is totally different than a plastic bottle.
Yeah, and what's in it, and whether it's liquid or powder.
Exactly. And so we all were kind of like, oh, this is actually pretty scary, the concept, right? And so
Yeah.
Yeah.
we started brainstorming like on the fly in the last work session, like we got some other ideas, but we kind of immediately ran into barriers like, well, okay, those ideas would immediately preclude, for example, multiple infeeds on the same section of track, kind of stacked
Yeah,
back to back,
right.
right? And we're
Mhm.
like, well, if you want to do rainbow packing, like that would be the way to do it, but it's an interesting idea to tack on the flexibility of rainbow packing onto this system, even though it's not required. And so the question is, to what degree is that an interest? And to what degree we say, you know what, just cleave it off because you can solve it with
I think
more
rainbow
track.
packing is really interesting, but
Yeah.
I think to try to solve rainbow packing and the kind of case and product flexibility in the same machine might be like more than like let's do that for the next machine, or like
Okay.
let's imagine a rainbow merger that feeds this machine, or like there's different
Yeah.
like um, so without like
Yeah,
dissing rainbow
exactly.
packing, like
Yeah,
love
yeah.
rainbow packing, like
Yeah.
we hear all of the end users just salivating over the idea that they could do their
Right.
own rainbow packs, they wouldn't need their co-packers.
Yeah.
Like
That doesn't seem
everyone's
like.
shaking and like, or they're
Yeah.
like salivating depending on what side. But like, so yes, rainbows, great, rainbows and unicorns, awesome. But like, let's just make like there is a case where we're saying let's revolutionize this as it exists now.
Yeah.
I mean, because I think rainbow packing is interesting because there's a whole different set of opportunities there where it's like you wouldn't have to unpack everything, you wouldn't have to like inline. It's very cool, but like I would say like let's leave it out. Does anybody object strongly or think we could do it
The
easily?
feeding mechanism that does the rainbow pack selection could be done upstream with much simpler automation than, putting a bunch of super fancy track.
Yeah.
Right. So I think leveraging this for the core function, which is serving up product, doing a dynamic buffer and serving up product, with variable pitch.
Mhm.
Yeah, multi in, multi out. Like that's what I think the core to me at the throughputs.
Yeah.
At the throughputs, and without the combinatorics of machines we've seen that like this. They have many
Right.
robots that all have many tools. This is exactly the kind of multiplication that you're talking about, where you're like, well, we can only do this many,
Yeah.
and then you're back saying no to your CPG marketing people who are the ones in charge.
Okay. So tell me more about what you've done with, there was the example that we saw was, case packing a 2x2 arrangement into, a row of incoming cases. It looked like those cases were stationary. Have you done timing models, timing simulations
Let me
with?
show you. Let me see if I can find that deck. Before you put that on screen, just a second. Let me. It's already here.
Look at that.
It's just like we did it. This is the
Yes.
last time I opened my computer. Okay. Okay. Let's see. Is this gonna work? Aha. Okay.
So that's 2x2.
I'm just gonna watch carefully.
Oh, it's changing on the fly. 2x2.
This video is not changing on the fly. Oh, yes, it is.
Oh, there
There's
it
three
is.
packs.
Okay.
You can see three packs now.
Wow. Okay.
Yep.
So what you see on here is a cases per minute. That's kind of like a synthetic average. You have all the shuttles, and the way we put this on the agenda was timing study, right? We need some timing studies. How often are these boxes going to need, cases going to need to shift? Which is, we didn't model the case shift in here, but at the time that we did this, which is probably a year ago, we didn't have the same kind of robotics tool. So the other visualizations, this is a fake out on the track, right? Ari did a really good job of faking the track motion components of this. It's just so that people can see what's going on. Because you look at this and you're like, oh, there's a bunch of green dots flying around. What the heck is that? Right? Yeah. So the truth is some combination of those two. It's not going to play it for me. Okay. And so we have basically we have timing studies of this is, I think we did 4 and 6 packs at the product rates, which are a few hundred a minute, I think. 350, 400, something like that. And the cases are either 50 or 75, and that case per minute shows you 50 cases a minute. And one of the interesting things about this process is like you have a laminar flow zipper infeed on the bottom that needs to have a shuttle there when the product arrives. Otherwise, it's going straight onto the ground.
Yeah.
You need to have enough ready. You see them kind of back up. You almost see a little tentative buffer. There's always a product shooting by that upper right corner, right? It's almost continuous, right? And then you have to stop them so the robot can pick them up, and then you have to shoot them around the corner really, really fast. All that has to be like net flow of 0, right? And so we have timing studies of this. We play with number of shuttles, track length, like different elements like this. I think it would be a good idea to make this higher fidelity, to have somebody be like, dig into the timing studies.
Yeah.
Let's make this a little more articulated. Maybe we could combine this with the robot studio thing and kind of have some dual digital twin situation. That would be killer.
Yeah, right.
Yeah.
The two things that are really dictating the physical size of the track are the robot time between the second pick, and the placement. Right. That's like a major chunk of time to actually drop into the cases. And then the other thing that is...
It's the between picks, too. Because it's the shift. It's kind of subtle, but like when it goes all the way back, like that's actually really helpful for getting a whole new row of product in. It's when it does this little shift. Like, anyway, it's all...
I see what you're saying. Yeah. Because you have to have a whole row of product backed up, ready to load into
Almost,
Yeah.
You see them at that green dot kind of backing up as the buffer. They're like ready to shoot in there.
Yeah.
Right.
Yeah.
As soon as the robot's ready. And like I mentioned, at the time we did this, we were just guessing like, well, is a half a second for a pick move enough?
Yeah.
And is 2 seconds? And then we did it in Robot Studio, and it looked good.
Yeah.
In fact, we felt like we might be able to do better. So that would be a more complete and more intricate timing study would be worthy.
Yep.
And we're also wondering if we could take some of the straight track section out, because that would be nice.
Return of those I guess they don't have any product in them, but the return is wicked fast. I guess that's faster because there's less product in there, so you don't have to worry about launching the product.
That's why it's fast. Yeah, that's correct.
So the other major thing that's taking up time is this gravity feed, right? On the in-feed, there's just a certain amount of time you need to accommodate for the product to be able to slide down onto the thing. So
and that's a function of the linear speed and the steepness and the product stability, and that's something I don't imagine is just going to work. It's not going to work for every product every time, but it's something that for a family of products we could probably get pretty close, or we could have it be adjustable somehow.
We're envisioning a new, a different in-feed architecture that would basically come in right over here, and on an in-feed conveyor kind of downward at an angle that comes in kind of orthogonal to your tooling. And so it would happen much faster. It doesn't require a second of drop time. So that would actually increase the amount of buffer we have here, which is good because it means.
Or you could shorten the track.
That would be interesting.
Does the in-feed mechanism you're talking about not depend on fixed tooling? Because when we were talking with Stacy, he was talking about rings and
No, it's no.
Maybe that's something we could come back and
Yeah,
you guys
exactly.
could update on next week on Tuesday.
It's
We should probably try to draw something.
Yeah. We should draw something because it's too hard in 6 degrees of freedom.
Hand waving, yeah.
One of the risk factors seem to be relying on gravity at high speeds. I feel like you just can't trust gravity, but
it's a law.
It's pretty reliable.
Theory? Oh god. Yeah. We're not moving at light speed, guys. I don't know. What I want to. So let's actually make that an item, which is when we first had that cocktail napkin of, hey, how about it slides down on these rails? Like, we had a similar feeling of trepidation. Like, well, that's no way, that would never work. And then when we were chucking the product at it, it worked really reliably. I mean, we didn't build like a cross thing, and so I guess one of the things I'm feeling or I'm noticing is prototyping. Like, okay, how unreliable is
Sure.
We think gravity's unreliable. Let's build some slides. Like, let's build some conveyance slides, and like let's convince ourselves one or the other. Like, we could build stuff out of duct tape and whatever the heck is lying around here,
Oh yeah.
and chains. Like, we don't have to solve every aspect of it, but if we could demonstrate if we could prove or disprove,
Sure.
this is this is brilliant, or we need to start over. Like, that, we would know that really quickly. So I mean, one of the things that would be interesting to come back with, or maybe one of us can do, is say, like, what would a prototype of a gravity in feed test look like? And we get some sample products and we try it.
Yeah.
It could be just everything fixed and on the same pitch, but we need enough time to get up to speed and kind of come to the ledge and go down the slide. Like,
yeah.
Angle changes, or I don't know. We could just build it out of like rails, like extrusion stuff.
Yeah. I we should mock up what we have as another idea.
No, right? Yeah,
might even be better, and I think so that'll be a good one for.
We should make somebody specific
week.
responsible for that, though, like, so that we can kind of we have a time study, interesting kind of thread. We have a in-feed mechanism. Maybe we should like make somebody lead of either one of those. And
yeah, well, you can take a stab at the in-feed mechanics drawing.
Yeah. Okay.
Yeah, the timing study. What about the timing study?
There was some. You had expressed like, we don't know if we have enough time for certain things to happen, and it could even just be like, let's dig up the time studies and look at them.
Yeah. I think there are some fundamental assumptions that I'm concerned about with the timing study. I want to look at how sensitive, I guess, the sensitivity of this model, right? Because like, if we're off by half a second on the robot placement time, like, what consequences does that have, right?
Yeah, and we'll see the throughput number right away, because this is running the real track code,
right?
And so we can change our assumptions, and we can fiddle with. We can look at sensitivity to that.
So, Jonathan, do you want to take that on? Okay.
That's what I wanted to do.
So, basically, pull this simulation up, and then what I'd like to do. Question for you about the case packing. So, what the simulation I saw assumed a stationary set of cases, and my concern is that in the amount of time that we've got here to that we're stacking up 4 products, can we, or whatever, all these products, can we get index in all of these cases in that amount of time?
We can measure that time off this chart, off this simulation.
Yeah.
And what I would emphasize is we have both row picks, like, move back here, okay, we're clear of the box. Okay, that's when the box can start moving. We come here, we get the first row, we do a shift move, we come here, get the second row, we come all the way back, now the boxes have to be there. So that's actually a big fraction of the cycle time.
Yeah.
And so again, we got to look at it. It might be a little scary to be like zipping the cases.
It looks scary here, but when you in your mind, when you do the accumulated time, so but
we can measure it, and then we'll know, like, okay, here's the triangle move that
right.
whole.
Because the alternative is you assume it's a continuous process, and then the robot has to make up for the it has to actually advance and then drop in it. So now the robot's doing a lateral, a move in this dimension, as opposed to just kind of.
And that's exactly why we had said, like, we don't want, if it moves over here, it has to move back. If it wants to get up to speed and move with, or pick them off of moving shuttles, like right. Just move as little as possible.
Like, move the big stuff
tiny as possible. Yeah. And again, that was why we didn't try to, like, why are we having a robot try to match the dynamics of individual tracks and even a whole set of boxes?
Yeah.
Like, the robot's like probably the slowest.
Also, not to make things complicated, but
we're making it complicated.
The end effector has.
We're at 30 minutes. Let's make it complicated.
Has translation as well, so like you could.
The end effector. Yeah. Right. Yeah.
But. Yeah.
Now you're talking.
No.
now how are you going to rock those into the case? Octopus style.
Okay, cool. So I guess that clarified a bunch of things. I'll write this up.
One thing I want to add on the in-feed, and then we can wrap in a few minutes unless we have like stuff in people's minds.
I think we're good.
This slide mechanism was kind of the simplified version of this there was also discussion, I don't know if you remember, at the Ondex Beer Hall in Munich in November of 2018.
Probably.
Um, you have the linear feed coming in. It's at an angle. One of the things that we were worried about was like one of the ways to do it was transfer it onto an intermediate fixed pitch V, like big ass V, right?
Mm-hmm.
So you're either dumping it directly onto a V where like it's pulling a gap enough where like the largest product fits, but for small products it just like goes in one by, like it just kind of singulates into like a fixed V belt,
Mm-hmm.
fixed V, each one is like a big tub.
Right.
And then you just like zipper the track to those V's,
Mm-hmm.
because that way like all of the like loosey-goosey transition would be like, you could run at a pull rate that you would know like exactly one is going in
It's
per
supported
cycle.
all the way down through the V as a product slides down onto the shuttle.
Yeah, that too. Yeah, and you could totally interleave them as well. And
Mm-hmm.
that way it wouldn't be going from like this like sort of planar thing. If you go from planar into like a big ditch, and then it would be ditch onto rails, like. So if you're thinking about in-feed mechanisms, like there was like some talk or notion of like this two-stage thing. And if we like that better, of like chucking it this way, or kind of having some, or even just having a double waterfall, like I don't know, whatever you want to call these, like.
So a fixed pitch V belt that
But a big
can
one.
accommodate the biggest product, and
Mhm.
smaller products will just roll.
They'll
into
just
the
settle
middle.
in there. Yeah.
So you have to have some vertical separation so that they have time to settle in before they actually enter the grooves of the end effector.
It seems like the timing between the product in feed and that fixed pitch belt becomes pretty critical to make sure you don't get like two products into one V and that sort of thing.
You would need, the proportion, the speed proportions based, because the product pitch is going to change. So like the frequency is going to be different, and then also like the phasing of it, and then like we talked about, like, oh well, if you phase one and you're like, oops, like there's a blank one, like what does everybody do about that? Because it could be just we don't put a shuttle under a blank
I
one.
feel like the shuttles can gear into the product as a product's, like if we can detect the position of the product, we can gear the shuttles to match, right?
Yeah, and the cool thing too would be if you missed a V, if you had an empty V, you'd be like, well, we need to phase the zipper back
Right.
to the next. That would be so cool looking, and cool working.
Yeah. So the other in-feed idea could also, you could have a hybrid of those two ideas, meaning you could positively capture the incoming buffer with, essentially a double-sided conveyance, right? And then shoot them into these dispense. You know what I mean? You dispense them into the grooves.
We can
as opposed
you
to
guys can
dispensing
go
them into
deep on
shuttles.
this, and
Yeah, we can.
That leaves your recirc track open, so it's cool.
we
Okay.
haven't got it. So okay, I think we should wrap pretty shortly. We haven't really. I think these are the most important things to consider. There's still this notion of track architecture, but the more we talk about I think maybe we save that till later, like, because it's still interesting to me that there would be like divert opportunities, and like what would that allow for us. But like, I think let's save that for future weeks. Like, do you guys agree?
Yeah.
Okay.
One other thing I noticed on the, if we can go to the end effector
Sure.
slide.
Which one do you want?
Side view. This view's fine. I was noticing that it's optimized for 2 rows. It seems like you're going to end up
Yes,
with
it is.
cases that have 3 or 4 rows, like 3x4, 3x3s, those sort of things. Is that just accommodated by only loading, like doing multiple picks and places into individual boxes and only loading maybe half of it for one of those, or what's kind of the general plan?
That is an open question.
Okay.
And I think that's where maybe it starts getting a little more dependent on product, like what are the product attributes, and like what is the shape of the product, what's the cap of the product, like how do we grab the product, and the only thing that this shows, in my opinion, is like the end effector can move through the rails, like, and so if that was suction cups and is suction cupping a bunch of them, and you just have a big grid and you only fill part of the grid if it's like not that many rows, or you like need to accordion the grid, like there's a whole combinatoric mess waiting there. So one of the simplifications, and one of the things we look at is like this product matrix happens to only use cases that have 2 rows.
Mm-hmm.
So we can either like throw a whole wrench at this later, or we can pick a product, kind of find a product that's specific that we could do the end effector tooling to.
Sure.
You've mentioned simulations a few times. We've got a comment on the chat.
Yeah.
Basically talking about how the BNR has a program called, I believe it's called Scene Viewer, that allows you to simulate the accomplished track.
You will notice that this is the output of Scene Viewer as of a year ago. So yes, this is the 2D version of Scene Viewer. So thanks to that watcher, we'll update it. Sorry, I'm talking to the wrong camera. Thank you, whoever you are. And we will be digging back into these Scene Viewer files and doing more Scene Viewers. And it's obvious we should be working towards some kind of unified Scene Viewer situation where we can see in 3 dimensions all the stuff. And whether that's Robot Studio, Scene Viewer, or some fancy Loupe Web HMI situation. Look at our other things for Web HMI. But yeah, we'll be using all those tools and more.
Yeah. Okay, so I think...
Any other questions or any? Cool,
okay,
thanks, man.
so one thing we determined was that the rainbow packing we're going to shelve as a requirement, so that's good. So that means we're at liberty to at least mock up alternate concepts. We still have clarification to explore around system requirements, but I think that gets us a lot closer to what we needed to know. So Nathan's going to mock up alternative concepts for the infeed. Jonathan's going to get back into the timing study, so we can look at sensitivity to timing and pick and place, and we'll review infeed concepts.
And we'll do all that with enough time to do our regular jobs and at low enough fidelity to come back on Tuesday at 1 p.m. Pacific.
Right.
Different time because of a conflict that I have, but 1 p.m. on Tuesday. And napkin sketches are welcome, whiteboard is welcome. Kat, do whatever you can do in the time to like help us come together and have a design discussion about it. Cool. Anything else? Are we good to go?
We're good.
We are good to go. All right. Well, thank you for joining us at Live at Loupe, where we talk about weird machines and robots and argue about requirements and figure out how stuff should work and not know what's going to happen next.
No arguments today.
No, just fun discussions. So, yeah, stay tuned for that. Maybe there'll be one next time. Bye-bye.
See ya.
Thanks.
All right.